Greetings and welcome, mis amigos de algebra. We were talking about solving absolute value equations, graphing absolute value equations on a number line, and here's the quest from last night. It says, match the absolute value equation with its graph without solving the equation. I mean, I know generally you guys would be thrilled if your math homework, like if they gave you a bunch of math problems and just said, don't solve these. And then like you'd be like, oh, I was going to do some math, but I guess I don't need to anymore. But here we go. We practiced this a little bit. I had my absolute value grapher on Desmos the other day. And one of the things we realized was the following, was that the midpoint was the opposite of this, right? So -2 was the midpoint of my graph. And the distance my solutions were from that midpoint were this number. So which of these graphs have a midpoint at -2, the opposite of +2, and then solutions 4 units away from it? It looks like over here, right, -2 is the midpoint, and then 4 units away, I get solutions at -6 and 2. So it appears as though the solution here is B. Over here, the midpoint would be +4, and those distances, Ethan, you can keep that phone away, thank you, is +2. So it looks like, let's see, -4, +4, and a distance of 2 away, 2 away. So it looks like D is the answer to 28. A little tricky to do these without solving them, right? Right. Over here, the midpoint is going to be +2, and the distance is going to be +4. So +2 and then distances of 4 away on both sides. C will be the graph of the solutions for 29. 29. And lastly, for 30, the midpoint is -4. Right, that's the tricky part, is it's the opposite of that. And the distance away from -4 is 2. So let's see, so -4 and then 2 away, 2 away. You can see the solutions there are A. So if I wanted to actually pick those solutions, -6 and -2, if I wanted to check them, right, is -6 plus 4, that's -2, and absval does equal +2. And then how about the other one, is -2 a solution? -2 plus 4 is 2, and the absolute value of 2 is 2. So those solutions do in fact work out. It's a little bit tricky. You just got to get used to this idea of the midpoint and the distance is how that ends up working out. Let's and then here's the same idea, just applied a little bit more generically. So notice they defined the midpoint as B, right? And we knew that our midpoint was subtracting B, so they already had the minus sign there, so I didn't have to make it a -B. And they used a little bit of a different letter than I did earlier. They called the distances away D, so this would equal D up there. So I had a little bit of a different name for it. And then their solutions were here and here, right, for that equation. And let's see. Oh, I've got one more. A good old solving problem. Oh, look at this. There's a problem like this on your test in a couple days, by the way. It's a golden problem here. And really importante is check your solutions, because they might be lying to you. Oh my goodness, that's terrifying, especially on Valentine's Day. Betrayed by my solutions? Oh my goodness, horrifying. So the first thing we do, once the absolute value is by itself, we break it up into two separate equations. So either 6a minus 5 was equal to +4a, or 6a minus 5 is equal to -4a. Two possible situations. Either the inside was positive or the inside was negative, and so I account for both of those. And now I just solve normal style. Subtract 4a from both sides. You could have moved the 6a and saved yourself a step, I suppose. 2a minus 5 equals 0. Add 5 to both sides. Oh, this is going to be a fraction, which is a pain for checking, but it's doable here. Divide both sides by 2. and I'm going to get a equals 5 halves. Now, I don't know if that solution actually works for this problem yet, so hold your horses. Over here, let's move the 6 first this time, even though it'll give me some negatives, because there's a bunch of ways that you can make algebra work for you. As long as you obey the laws of math, you will all eventually get to the same solution. Let's see. Oh, man, it's been like a few days since we've done algebra. How would I get a by itself here? Divide. I'm glad you said divide. Sometimes people want to add 10 to both sides, but that negative 10 is being multiplied by a. The inverse operation would then be division. All right, let's see. How many of us remember what a negative divided by a negative is going to be? Positive. So a is equal to a half, or let's write it that way. A equals a half. So the issue is that I don't know if any of these work without doing a check. And fortunately, I only have one problem like this on your test in a couple of days, like I was saying. So let's check it. Check it like a basketball on half court when you're playing a game, right? Here we go. 6 divided by 2 is 3. Notice how I do my fractions here. Not that fractions are the thing I'm emphasizing, but it's good to know how to do these, right, Amity? 6 divided by 2 is 3. 3 times 5 is 15 minus 5. Is that equal to 4 divided by 2, which is 2, and 2 times 5 is 10. Oh, this is looking good, friends. Abs val of 10 is equal to 10. True story. True. Let's check the other one. So that means I can box this. That's golden. I like it. Oh, wrong color, Mr. Waddy. Let's check the other one. So is 1/2 a solution? 6 times a half minus 5. Is that equal to 4 times a half? Now, there's no concern about this equaling a negative, right? That would be an immediate concern for me. 6 divided by 2, or 6 times a half, is 3. 4 divided by 2 is 2. Uh-oh. What do you guys think? Is it going to work? 3 minus 5 is negative 2. Oh, but abs val for the win right at the end. Oh, it worked. Excelente. So that means both of these are solutions. So A was equal to 5 halves, which is about 2.5 exactly, or 1/2, which is like 0.5. But I'm a fan of the fractions. Thanks for watching, internet friends. Tienen un día el más bien del mundo.